Assalamu alaikum everyone. Wa alaikum salam to everyone who said salam. What's up? Long time? Wa alaikum salam. Yeah, a lot of new stuff. Can you guys count all the stuff that's new? Sir, I got 92 in additional maths and 96. Whoa, that's great. MashaAllah. Congratulations to you. New background. No. Yeah, I mean, if you're talking about the stream background, then yes, that's new. What else? Yeah. Although I still haven't used the Stream Deck yet, but microphone interface, yes, that stuff is new. Can you do numerical solutions? What do you mean by that, numerical solutions? What's that supposed to mean? Is B a bad grade in advanced? No, not at all. B is a pretty decent grade. Advanced is a challenging subject, so getting a B in it is pretty good. Walaikum salam. Alright, so let's start, shall we? Thank you for your motivation for AdMath and O levels. When did I do that? I don't do motivational videos. Should I watch this for O level AdMaths? You can if you want. There's no harm. But A level, AS level differentiation is actually easier than AdMaths differentiation. Although the concepts are easy, but the difficulty level of the questions can be high. Sir, I wanted to say thank you so much for. All right, you're welcome. You're welcome. I'm happy for you. A is a good grade, almost as good as an A star. So yeah, pretty good. 4 A star, 4 A's. That's great. Nice. So you guys must have gotten some really nice scholarships. Slow mode off. I think this has been on since. Okay, I'll turn it off. Don't worry. Slow mode. Okay, there you go. Sir, I saw you near Clifton, Karachi. That's possible. When? Today? There's another detailed video, inshallah, coming very soon regarding the result. We'll give you guys like a direction. Hopefully, that's what the idea is, and I'm sure you guys will like it. Failed in maths. Sorry, I guess. But yeah, if you failed in maths, make sure you don't leave it there. Make sure you improve your grade. So I got 98 in economics O level as well. Hopefully a world highest or country highest. Okay. Anyway, so shall we start? Anyone who'd like to be a moderator? So I got B. Is B bad in AS Math, B1 and S1? First stream after a long time. Yes, not the first live stream for AS Math, but first stream after a long time. Walaikum salam. So I got B in O level math. Should I take A level? B in O-level math, should you take math in A-levels? I mean, if what you want to do really requires you to take math, only then will I suggest. Otherwise, don't. Okay. So I'm studying maths in AS and looks difficult. It looks difficult. Is it normal? Yeah, it is difficult. Of course, it's a higher level of math, so it is going to be difficult. Okay. Anyway, so let's start. I would appreciate if you guys would just like the stream. We're already late. So yeah, as you can see, we're doing differentiation. Okay. So there are a lot of concepts in differentiation. I've written them down over here. You can see that you have to first there is why use differentiation. Okay, so we'll look into that. IGCSE students, IGCSE Math students do differentiation in math, so you guys will have an idea as to how to differentiate functions. Okay, and then we'll learn how to differentiate the types of functions that we're going to be dealing with: power functions and composite functions. Okay, so we'll basically learn power rule and composite rule. Then we'll learn how to find a gradient at a point, fairly easy. We'll learn how to find the equation of tangent, lengthy but easy. We'll learn how to find out the equation of normal, again lengthy but easy. And then we'll learn how to find out the stationary point and its nature. So all of that is part 1. Okay, so this is going to be divided in 2 parts. So this I will do today, and tomorrow inshallah we will do this. Okay, so this is part 1. And by the way, you guys can download some past paper questions that I've taken out, and once we're done with this stream, I'll upload these notes as well, so you guys can have a copy of this. Okay, so let's start with part 1, which is why do we use differentiation. Okay, so why do we use differentiation? Let me ask you guys, what's the main purpose of using differentiation? Like, what's the one thing we use it for? So while you guys are answering that question, I'll just quickly make 2 graphs. So let's say we have a straight line here, and let's say we have a curve here. Gradient, yes. Sir, will there be any other chance to join your online course? So there is a waiting list. Okay, registrations are closed. There is a waiting list. You can fill that up, and if a spot opens up, either me or one of my team members will be in touch with you. Okay. All right. So yeah. So the reason why we use differentiation mainly is to find out the gradient of the curve. Okay, gradient of the curve at any point. And the reason why we don't do that in a straight line is because if you want to find out the gradient, you can pick any 2 points in a straight line and find the gradient. Okay. So in a straight line, the gradient, or m, is constant. Okay. Gradient is constant. All right, and how do you find out the gradient? You use the gradient formula, which is y2 minus y1 over x2 minus x1. Now, before differentiation, there is another method which we use to find out the gradient of a curve at a point. What is that? What do we make in order to find out the gradient of a curve at a particular point? It starts with the letter T. The next live stream will be tomorrow, and tomorrow we'll be doing part 2 of differentiation. Okay. Tangent, that is correct. So one way to find out the gradient of the curve is by making a tangent. Okay, so let's say you want to find out the gradient of the curve at this point right here. I'll call it x1. Now this is not drawn to scale, it's just a rough representation. So if you want to find out the gradient of the curve at x equals to x1, what you're going to do is you're going to draw a tangent, okay, and then you will find out the gradient of tangent. Okay, so gradient of the curve at x equals x1 can be found by drawing a tangent at x equals x1. Okay, but this is obviously a longer way, and this is not very accurate. Okay. So that is why we use differentiation. Okay, so an alternative to that is through differentiation. All right, so how do we use differentiation? Let's see. the way that we use differentiation over here, so I'll just give you a quick overview of it. Obviously, we need to first learn how to differentiate so that we can learn how to use it. But here's how we use differentiation. So if, let's say, we were to do this through differentiation, let's say the question said, find the gradient of the curve. And let's say this curve is y is equals to fx. Y equals to f of x at x equals to x1. Now this is like just a generalization of the concept. Okay, so if you don't understand what I'm doing over here, it's okay. Once we do some questions and once we learn how to differentiate, this will make more sense. Okay, so this can be done using simple 2 or 3 steps. Okay, so 2 steps in fact. So step 1 is that we first differentiate the function. Okay, we first differentiate the equation of the curve, which we say find dy by dx, or you can also call it f prime of x. Okay, now what do we call this? We call this the gradient function. Okay, once you differentiate a function, once you differentiate the equation of the curve, what do we call it? We call it the gradient function. Gradient function. Okay, then comes step 2. What's step 2? Step 2 is that you plug in x equals to x1 in dy by dx. Okay, now when you do that, you will have a certain value. Okay, and that value will basically be what? That value will basically be the gradient of the curve at x equals to x1. Now when we say gradient of the curve, it's not exactly the gradient of the curve that we're talking about. We're actually talking about the gradient of tangent to the curve. All right. Yeah, you're gonna get M1 videos as well, inshallah. So this week I will do P1. The week after, inshallah, I will do M1. Let me know what topics of M1 you guys want me to cover. Okay, let me know. Okay, yeah. So this is what we do. We first differentiate, okay, and once we have the gradient function, we plug in the equation, the x value, and we find out the equation of the curve. Okay. Now the question is, how do we differentiate? So this is why we use differentiation. Now let's talk about how to differentiate. So we'll do some examples, okay, and through the examples we'll learn some important rules. All right. So there are two main functions, two main categories of functions that we should know how to differentiate. One is the power function and the other is the composite function. Okay, so let's talk about power functions. So the way we differentiate functions that have a power in them is this. Let's say you have y is equals to 5x to the power 4, okay? And you're asked to differentiate this. So what are you going to do? First of all, when you differentiate y, this becomes dy by dx, okay? And then what happens? Then it gets multiplied. The power gets multiplied by the coefficient. So 4 into 5 is 20. And then you take 1 away from the power. So what's 4 minus 1? That's equal to 3. Do I have a video on quadratics? No, I don't think I have a video on quadratics, but we can always do a live stream on quadratics. By the way, how many of you who are watching right now are giving math in October, November? I'd like to know. And while you're doing that, I'm just going to do another example. Let's say we have y is equals to 4x cubed. Okay, how are we going to differentiate this? The way that we're going to differentiate this is simple. 4 times 3 is 12, so that's 12, and we'll take 1 away from the power, so that's 12x squared. Okay, so there you go. That's it. That's the answer. Now, let's say we have y is equals to 9x. How will we differentiate this? That's pretty easy. So what's the power on x at the moment? That's 1. So 1 into 9 is 9. And what's the power on x going to be? It's going to be 0. But we don't write it as 9x to the power 0. Instead, we prefer to write it as simply 9. And that is what dy by dx of y is. Okay. All right, best of luck. And you guys didn't answer my question. What topic of M1 and S1 do you guys want me to cover? Do let me know. Okay, how would you differentiate this? Y is equals to 5. Y equals to 5, yeah. How would you differentiate this? Yep, that is correct. That is going to be 0. Good job. The answer to that is going to be 0. Okay. Now let's write down some general rules over here. Okay, some general rules that will help you remember the concept. Okay. So general rule number 1, which is if you have a function that resembles this, y equals to ax to the power n, how are you going to differentiate this? Dy by dx is equals to n times a x to the power n minus 1. Okay, that's it. That's the answer. If let's say you have y is equals to a, where a is a constant, that means it's a value. Okay, it has no variable with it. In that case, what is dy by dx going to be? Dy by dx is going to be equal to 0. Okay. Now, in some cases, you might have to sort of go the extra mile. Okay. And what do I mean by that? By that I mean you might have to first make the question differentiation ready. In the sense you have to first wouldn't okay, 9 to the power, it's going to be, okay, wait a minute. 1 gets multiplied by 9, that makes it 9, and then x has power 0, and the power 0 is only on x, okay? So that is why x power 0 is 1, 9 into 1 is 9, okay? And the answer to this, I didn't write this down, so in this case, dy by dx is equals to 0, all right? It's not 9 to the power 0, it is 9x to the power 0, okay? And we don't multiply 9 by 0, we multiply 9 by 1. Okay. Yes, I do take O-level math classes online, but at the moment, registrations are closed. There is a waiting list, which you can find on my Instagram somewhere. You can fill that up, and if a spot opens up, one of my team members will be in touch. Okay. All right. Now, like I said, there are some cases where you first have to make the function differentiation ready. Now, what do I mean by that? So let's say you have the following. Y is equals to 5 upon 3x squared. Now, you can't just start differentiating this immediately. You first have to make sure that it's written in a way so that you can differentiate it easily. Okay. How would you do that? What exactly are you going to do with this so that it's easy for you to differentiate? Question for you guys. What are you going to do with the power x? Sir, how variable is 0? Okay, variable is not 0. It's the power on the variable that's equal to 0. Okay, and this here, okay, in case you're wondering why this is 0, so this can be written as 5x to the power 0. 0 gets multiplied by 5, and everything else then becomes irrelevant. 0 into 5 is 0, and yeah, that's it. Crash course for May, June, or 2024, or October, November 2023? Talha? Okay, so first thing we're going to do over here is we're not going to differentiate it immediately. So we will first write it as 5 upon 3 x to the power minus 2. Okay, so what I've done is, what I like to call this is that I've made it differentiation ready, which is just a fancy way of saying that now it is ready to be differentiated. Okay, so now we can go on and differentiate it. So dy by dx is equal to minus 2 into 5 upon 3. So that's going to be minus 10 upon 3. X to the power minus 2 minus 1. And let's see, what else do we have? Dy by dx. We can simplify this now. Minus 10 upon 3. X to the power minus 3. And that's it. That's the answer. Okay. Now, of course, you can make the power positive. You can make the power positive and write it like this. But that's up to you. If you don't do that, it's perfectly all right. Okay. All right. All good so far, I hope. Okay, let's do another question. Let's say you have something like this. Y is equals to 2x minus 5 upon x squared. You guys want to give this a shot? Okay, I'll give you guys 2 minutes. Give this a shot. No, I will not. Sadly, I will not be doing a crash course for October, November, but rest assured, I will be doing lots and lots of live streams to cover P1, M1, and S1. When you guys have the answer, do let me know. Two minus 2 upon x square. The crash course for AS May June. Normally I do a crash course for IGCSE and O levels. If I do a crash course, it will start in January, but that is if I do it. Okay, it's very likely that I won't, but if I do it, it will start in January. Okay. Anyway, so I can see some of you have given the answers, and I think that's correct. The correct answer is minus 2 upon x square plus 10 upon x cube. Yeah, that is the correct answer, but I'll do it anyway. So first we'll separate the denominator so that it's easy for us to differentiate. Okay, so you need to add some layers of working over here before you can start differentiating it. Okay. Next thing you want to do is you want to simplify 2x and x square. So this becomes 2 upon x minus 5 x to the power minus 2. And then you can write this as 2x to the power minus 1 minus 5 x to the power minus 2. Okay, so I haven't differentiated it yet. Now I will start differentiating it. Okay, so if I differentiate it now, here's what we get. So minus 1 gets multiplied by 2, so that's minus 2. X to the power minus 2. And minus 5 gets multiplied by minus 2, so that's going to be equal to positive 10 x to the power minus 3. Now you can leave it as it is if you want, and or if you want, you can make the power positive. Okay, so minus 2 upon x square plus 10 upon x cube. There you go. That's the answer. Okay, now these are some fairly easy questions that we have done so far. So what we have done is we have learned how to differentiate, and we've learned how to use the power rule. All right, now the questions can get complicated in the sense that there may be a lot of layers of working before you start differentiating it, but more or less they will revolve around the same concept. Okay, what we're going to do now is we're going to do the composite rule. All right, so let's do that. And do you guys suggest we do past paper questions side by side, or do you suggest we first learn the concepts and then do past paper questions? In fact, let me have a poll quickly. Okay, so there's a small there's a suggestion that I need from you guys, so please let me know. Okay, so the next is power rule. So power rule is basically when you have to differentiate a function that has like a whole power on it. Okay, what does that look like? Okay, we'll do it side by side. I think I have what I need. We'll do it side by side, so I'm just gonna end it. Okay. So let's say you have something like this. Hang on, let me open up a question. Yeah, so let's say that you have the following. Y equals to x plus 2, the whole thing cubed. All right. Now, one way to differentiate this would be that you first expand the whole thing. Okay. and then you plug in and uh, and then you differentiate it, okay, which obviously will take forever. That is not something I would recommend. I will not recommend that you first expand the whole thing and then differentiate it. Instead, there is a way through which we differentiate it, which is called using the power rule. Okay, so how does that work? Let me show you. So if I differentiate this, dy by dx is going to be equal to 3 x plus 2. 3 gets multiplied by x plus 2, and we take 1 away from the power. And then we multiply it by the differential of the expression inside the bracket, which means differential of x plus 2, which, by the way, is equal to 1. Okay, why? Because if you differentiate x, you get 1. Now, this takes a while to get the hang of. If you haven't gotten the hang of it, it's okay, nothing to worry about. We'll do plenty of examples, all right? I usually don't expect students to get the hang of it after the first example, all right? Now, let's do another question. Let's say we have something like this. Y is equal to, let's say you have 4 into 3x minus 1, the whole thing to the power 4, all right? So how are you going to differentiate this? Again, we follow the same concept. 4 gets multiplied by this 4 right here, which makes it 16. Then you have 3x minus 1 to the power 3, but don't leave it there. We then have to multiply this by the differential of 3x minus 1, the expression inside the bracket basically, which is going to be 3. And what's 16 times 3? 16 times 3 is 48. So 48 into 3x minus 1, the whole thing cubed, is what dy by dx is. Okay, now hopefully you guys are getting the hang of it. Yes, this is a composite function. So can you do past trivialize for M1? Yeah, I could do that. But past papers I will not stream on what do you call YouTube. I'll probably stream them somewhere else. Okay, where exactly we'll see. All right, because I don't know if you guys remember last year there was a problem because I streamed a recent past paper or something like that. Anyway, so let's do another example. Let's say we have something like this. Y is equals to square root of 2x minus 1. Okay, again, you can't just brainlessly start differentiating this. First, you have to make sure that it's written in a way that it's easy for you to differentiate, which means 2x minus 1, the whole thing to the power half. Make sure to write it in index form, not in surd form. Now you can go on and differentiate this very easily. So dy by dx of this function is going to be half gets multiplied by the function, so that's 1 upon 2 into 2x minus 1, take 1 away from half, so that's going to be half minus 1, which is minus half, multiplied by the differential of 2x minus 1, which is 2. So this 2 and this 2 gets cancelled, and now we have 2x minus 1 to the power minus half, or you can write this as 1 upon square root of 2x minus 1. Okay, this is something that's called a composite function as well. Okay. Oh, actually, yeah, I think that is what one of you wanted to point out. This is not power rule anymore. This is composite rule. Sorry, my bad. My bad. Okay. Yeah, maybe Twitch. I used Twitch last year, so I think I'll do it on Twitch. Let's see. Okay, so you guys said that we should do past paper questions side by side, so that's what I'm gonna do. First, let me write down the general rule for this. Okay, then we'll do past paper questions. So if let's say you have the following: y is equals to a px plus q, the whole thing to the power n. How would you differentiate this? So dy by dx is equals to n, which gets multiplied by a. Okay, px plus q, and then you take 1 away from the power, so that's n minus 1, which you then multiply by the differential of the expression inside the bracket, which is p. And what do you have next? As a result, you have NAP into px plus q to the power n minus 1. And this is your dy by dx. Now, there is a summarized version of this as well, so I'll share that with you guys. The summarized version is this. So if you have y is equals to f of x, and the entire function is raised to the power of n, so the way that you differentiate this is this. So you first differentiate the power, that means n gets multiplied by f of x, you take 1 away from the power, and then you multiply it by the differential of the power, which means f prime of x. And there you go, fellas. That's the answer. Not the answer, but that's how you do it. Okay? All right. So, any questions so far? Twitch is a dying platform, is it? So, who is Twitch competing with? Or who is competing with Twitch, rather? Okay, so there are some questions which I would like us to solve before we do some past paper questions. Okay. Okay, just a minute. All right, there you go. So we're not going to solve all of them. We're just going to solve a couple of them so that we learn how to find out the gradient at a certain point. Okay. So Twitch is still on top, but there are some up and coming platforms. All right. Anyway, we'll see about that. Okay, we'll see about that. So let's solve a couple of these questions. They're fairly easy questions. So it says here, find the value of dy by dx for each of the curve at the given point. So what we're doing now is we're learning how to find out the gradient at a certain point. Okay. So let me write that down that we are now. So by the way, we've done why we use differentiation, we've done how to differentiate, we've done power rule, we've done composite rule. Okay. Now we're learning how finding gradient at a point. Okay. Any tips for what? SAT? I don't think you're asking the right person. I haven't taught SAT in a very long time, so I don't know what to say to you. Okay. Other than, of course, just keep practicing the general stuff. Okay. Okay. So as I was saying, what do we have to do here? We have to find the value of dy by dx for each curve at the given point. So let me do part B. Okay. Now remember, in order to find out the gradient of the curve at any point, all you need is the equation of the curve and the value of x. So if I ask you, what's the reason of this y value? I mean, what's the purpose of this y value? It serves no purpose. Okay. In fact, you will notice that we're not even going to use it at any point. Okay. So y is equals to 5 minus 2 x to the power minus 1. So I haven't differentiated it yet. I've just written it in a way so I can differentiate it easily. So dy by dx is equals to 0. Minus 2 into minus 1 will make it positive 2. So 2x to the power minus 2. Alright, so what is dy by dx equal to? Dy by dx is equals to 0 plus 2 upon x squared. Now, I'm going to let go of the 0 because it makes no difference. What is the value of x that we're going to plug in? We're going to plug in 2. So if I plug in 2 in this function, so 2 upon 2 square, so that means 2 upon 4, which is equal to 1 upon 2. So that means dy by dx at x is equals to 2 is equal to what? Is equal to 1 upon 2. And that's it. That's your answer. Now, any questions? Anything that's not clear? If yes, feel free to ask. And see if you guys can solve part C yourself without my help. Take your time. Don't rush into it. When you have the answer, do share it with me. Functions. I have a video on transformation of functions, yes. And I have a video on composite function, domain and range of composite functions, yes. I do have a video on it. I did a stream last year, I remember. By last year, I mean like a couple of months ago. Okay, anyone who has the answer and would like to share it? Minus 5 upon 4, that is correct. Good job. So dy by dx is equals to minus 5 upon 4. Okay. All right. Now, that is how you find gradient at a point. But in questions like these, you will come across some challenging questions. So we're gonna do those questions through past papers. All right. This was just like an overview. All right. And let's do some past paper questions. By the way, I have uploaded a PDF of this. You can find it on. There will be a link. Let me see. Is there a link? There will be a Dropbox link. Yeah, there is a Dropbox link. Okay, where you can find everything. And once we're done with the stream, I'll upload these notes as well. Part B. Okay, I'll repeat part B. So first of all, write it in a way so that you can differentiate it easily. Then differentiate it. So differentiating 5 will make it 0. Differentiating minus 2x to the power 1 will make it 2x to the power 2. 2x to the power minus 2. And this is what you end up with, 2 upon x squared. Yeah, I think let's do one question and then we'll take a 5-minute namaz break. Okay. All right, let me find a question for you guys which we can solve right now. Okay, now this is an interesting question. So it does require the concept of finding gradient at a point, but it's kind of reversed. Okay. Now this I should let you know is from October-November 2020 paper 1 variant 1. All right, October-November 2020 paper 1 variant 1, paper 11 basically, and it's question number 6. So in this case, what we're going to do is, normally you would have a curve, you would differentiate it, and if you're asked to find the gradient at a certain point, you would plug in the x coordinate of that point in dy by dx to find the gradient. Okay, but in this case, sorry about that. Yeah, so in this case, it's slightly different. Why is it different? That is because we are given the gradient and we're supposed to find the coordinates of the point. Okay, coordinates. What does that tell you? Coordinates. It's plural. What does that tell you? That means that we will not only find the x coordinate, but we will also find the y coordinate. Left, right. All right, good luck to you. So here we have, here we have the equation of the curve, which is 2 plus 25 minus x squared, the whole thing to the power half. Okay. So we're going to differentiate this. Let's see what do we get. So dy by dx is equals to 0. All right, differential of 2 is 0. And here, be extremely careful. You don't want to lose marks by not differentiating it correctly. Okay, and so 5-mark question and 5 easy marks, I would say. Not very difficult. So this is what we get. So plus half gets multiplied by the function. Then you have 25 minus x squared. You take 1 away from half, so that's going to be minus half. All right. Then what do? We don't leave it here. We still have to multiply it by the differential of the expression inside the bracket, which is going to be minus 2x. Okay. Now, then there is some simplification that's required. So this 2 and this 2 gets cancelled out. All right. And now dy by dx is this. So we have minus x. And since it's negative half, I'm going to shift it in the denominator to make it positive, over square root of 25 minus x squared. Okay, let me make sure of that. Yeah, it's correct. Nothing wrong so far. Okay. Now, normally at this point, we would have a point where we're supposed to find the gradient. So we would plug in the x coordinate of this point. But in this case, we have the gradient and we need to find out the coordinates of the point. So what are we going to do in that case? Let's see. In this case, what we're going to do is we're going to equate it to 4 upon 3. All right, so that's what we're going to do. We're going to equate it to 4 upon 3. So gradient is 4 upon 3 basically means that dy by dx equals 4 upon 3. All right, so 4 upon 3 equals to minus x over square root of 25 minus x square. All right, now how do we solve this? Question for you guys. How do I get rid of the square root? This square root is a problem. I can't solve it while it's still there. So how do I get rid of the square root? What should I do? Minus 4 upon 5. Okay, the answer is correct, but that doesn't answer my question. My question is something else. Cross, yeah. So we're gonna square both sides. All right. Now you can square both sides first and then cross multiply, or you can cross multiply and then square both sides. Okay. So what I would do is I would prefer not rationalize. Rationalization is something we do when we have when the question says so. Okay. When the question asks us to give a final answer in a certain way. Okay. Anyway, so this becomes 16 upon 9. All right. This becomes, let's see, x square over 25 minus x square. All right. And then we cross, this is, now we can cross multiply. So if you cross multiply now, so 16 into 25, what is that? 16 times 25, that's 400. So 400 minus 16x square is equals to 9x square. Okay, then we shift everything over to the right hand side. So 400 is equals to 16 plus 9 is 25x square, which means x square is equals to 400 divided by 25, which is 16, which means x is equals to plus and minus 4. So what is x equal to? X is equals to plus and minus 4. Now we need to find out the value of y. Okay, so how do we find out the value of y? Let's see. Notice that the question says, now there's nothing in the question that tells us the value of x that we're going to take, whether we're going to take the positive one or the negative one. There's nothing in the question regarding that. Okay, so let's see. If I take x to be equal to positive 4, let's see what y is. So y is equals to 2 plus root 25 minus 4 squared. Now notice that irrespective of whether x is positive or negative, the effect on y value there will be no effect on y value. Why is that? Irrespective of whether x is negative or positive, there will be no impact on the y value. Why? Because of this. Here we have 25 minus 16, which is 9. Now because we have a x square, okay, because we have x square, so irrespective of whether you plug in 4 or minus 4, it makes no difference. Okay, so what is y equal to? Y is equals to 2 plus 3, which means y is equals to 5. And there you go. We now have the x coordinate as well as the y coordinate. So the x coordinates are plus minus 4. The y coordinate is positive 5. Okay, now, any questions? Okay, let's take a 5-minute break, shall we? And then we will reconnect. Sir, when will 2023 O level? Okay, they're already there. They are already there. Can y also be minus 1? No, not minus 1, because even if you plug in minus 4, you still get the same value. Okay, so irrespective of the value that you plug in, you get the same answer. Okay, I hope it's clear now. All right, anyway, so moving on. And by the way, the value of x that we're going to take, just so you guys know, the value of x when we're giving our final answer, the value of x that we're going to take, it will be minus 4. So minus 4 comma 5 is the final answer. Now why is that? Why are we going to take minus 4? Let me tell you. Because if you find the gradient, notice that the gradient is what? The gradient is 4 upon 3. Okay. Now, even though we're getting x equals to plus minus 4, but when you plug it back in, it is only minus 4 that gives us the positive gradient. Okay, so we will not take x equals to 4. Why? Because at x equals to minus 4, dy by dx is equals to 4 upon 3. Now you're very welcome to try what is the gradient when x equals to 4. You'll notice it's something else. Okay. That is why. In fact, when x equals to 4, if you find out dy by dx, you know what it's going to be equal to? Let me show you. So if you plug in 4 over here, so that means we have minus 4, and in the denominator, we'll have 3. So minus 4 upon 3, that means dy by dx equals to minus 4 upon 3. So the correct value of x that we're going to take is minus 4, and the corresponding y value will be 5. Okay. I will be doing streams on S1, inshallah. P3, if time allows, I'll do P3 as well, but S1 for sure. Okay. In tomorrow's stream, no. Differentiation of ln and e is not in AS. It's not in P1. It is in P3. Okay. Differentiation of ln and e is not in P1. It is in P3. We're doing differentiation that we have in P1. Okay. Why can't dy by dx be negative? Because the question says that the gradient is 4 upon 3. It's not minus 4 upon 3. So we have to first verify the value of x and then decide which value of x we're going to use to find the y value. Okay. All right. So like I said, let's take a break. Okay. So All right, so let's resume, shall we? Sir, can you explain how A levels is structured? So you have to get 4 papers altogether, okay? And A levels is of 2 years mostly, unless you want to do it in 1 year, then it's a different story. So what you do is P1 is what you have to give the first year, and P3 is what you have to give the following year. Now, other than P1 and P3, which are compulsory, you have 3 other components, of which you need to do 2. Okay, so you have M1, S1, and S2. All right. So M1 is mechanics. It's like a bit of physics. Okay. In fact, normally science students prefer taking M1. All right. S1 is statistics. So you have probability, permutation, combination, normal distribution, binomial distribution. S2 is like a more advanced version of S1. Okay. So if you take M1 with P1 the first year, then the following year you have to take S1 because you can't do S2. You can't do S2 without doing S1. But if you take S1 the first year along with P1 you have to take, then the following year you have the option. I mean, you're in a position to do either M1 or S2 because S2 has a prerequisite which is S1, so you've done that, and M1 has no prerequisite. So yeah, I hope that helps. Okay. So let's resume, shall we? So we've done finding gradient, okay, at a certain point. Now we will obviously do more questions of this. We'll do it through past papers, okay. But now let's focus on equation of tangent, okay. Equation of tangent and equation of normal is when things will start to get really lengthy, okay. Lengthy, not necessarily difficult, but lengthy, yes, for sure. Hello sir, can you please make a video for transformation and vectors? I do have a video. I will obviously make another one this year. I'll do another live stream this year, but I do already have a video on transformations and vectors. You can watch the O-level transformation video. It's the same. It will help you the same. Okay. All right. Now, equation of tangent. So equation of tangent has like 4 steps, I should say, that you need to follow. And through this, you can find out the equation of tangent. Now, remember, when we say equation of tangent, it's always tangent to the gradient. Okay. The question will be in a way that it will ask you to find out the equation of the tangent to the curve so and so at x equals to so and so. Okay. So yeah. Now we'll do both of these together, equation of tangent and normal. Okay. So let's visualize the situation here where we have to find out the equation of tangent. Okay. So let's say we have ourselves a curve. Okay. A quadratic curve. Could be any curve, but let's say we have ourselves a quadratic curve. Okay. And let's say on this curve there is a point which we're going to call x1. Okay. So we're going to do it in general terms. Okay. Not with actual values, but general terms. Okay. And this curve, by the way, has equation y is equals to f of x. Okay. And the question is that you're supposed to find the equation of tangent to the curve at x is equals to x1. Okay. Tangent to the curve y equals to f of x at x equals to x1. Okay. So the tangent line is going to look something like this. Right, this is what it's going to look like. Now you need to find out the equation of this straight line here. So my first question to you is, in order to find out the equation of a straight line, we need two things. What is that? Yes, congruency has been removed for students appearing in 2025 and onwards. Thank God for that. Never liked teaching that topic. Okay, so as I was saying, there are two things we need in order to find out the equation of tangent. One is the point of tangent, okay. And what's the other? Not really. Point of tangent means coordinates, okay? I get that. But there's something else we need. That is the gradient, okay? We need the gradient. No, not the coordinates of 2 points on the line. Remember, we're using differentiation. We need the gradient, okay? So here's what we're going to do. First step is, now remember I said that there are 4 steps, okay? So email them, okay? If you want to find out your component marks, email them. That's how you can, that's the only way to do it, okay? So the first step is, let me do this in red. Find dy by dx, okay? Or f prime of x by differentiating the equation of the curve. By differentiating the equation of the curve, okay? Now next thing you want to do is you want to find out the gradient of tangent, which means you need to find out the, by differentiating the equation of the curve. Yeah, which means you want to find out the gradient of a curve at a certain point. So how do you do that? We know how to do that now. That is that you plug in x equals to x1 in dy by dx or f prime of x, whatever you want to write it, to find out the gradient of tangent. To find out the gradient of tangent. Okay, now that's step 2. What's step 3? Step 3 is, now notice that in some cases it's possible that we have the x coordinate. Only in some cases it's possible that you're given the x coordinate as well as the y coordinate, okay? So if let's say you're not given the y coordinate, how will you find out the y coordinate? Plug in x equals to x1 in the equation of the curve. Now when you do that, you find out the corresponding y coordinate, which we're going to call y1, okay? And by the way, the gradient of tangent, we're going to call it mt. Okay, so now that we have everything, we have a point and we have the gradient. So what are we going to do now? We're going to put it all together and form the equation. So we have the gradient of tangent, which is mt, and we have the coordinates lying on the line, which is which are x1 and y1. And now step 4 is that we're going to form an equation. Form an equation. Now I'm assuming you guys have done coordinate geometry, and if you have done coordinate geometry, you would know that there is a different way through which we form an equation of a straight line, and that is y minus y1 is equals to m. Now m here would be mt, which is x minus x1. Mt into x minus x1. So this is generally how you can find out the equation of tangent at any point on any curve, okay? Now, what will we do? What is the one thing different that we will do in order to find out the equation of normal? Question for you guys. Answer this question. I'm just going to quickly grab a tissue. How will we find out the equation of normal? What's the one thing that we will do differently? Yes, we will take the negative reciprocal of it. Okay. So if you're asked to find out the equation of normal, this is what you're going to do. You're going to take the negative reciprocal of it. Okay. So this is what the equation of normal looks like. Okay. So let me just summarize that because we don't really have to do equation of normal from scratch. So, oopsie. So in equation of normal, here's what we're going to do. Y minus y1 is equal to minus 1 upon mt into x minus x1. Okay, why? Because the gradient of normal is basically the negative reciprocal of tangent. Why? Because it's a perpendicular line. Add math ki live stream inshallah week after the next week. Okay. All right, now let's do some questions. Okay, let's do some past paper questions to further get the hang of this concept. Okay, so there was a question which, yeah, okay, let's do this one. So it says find the equation of the normal to the curve at the point 4 comma 4, giving your answer in the form y is equals to mx plus c. Okay, so first step is pretty easy. What we're going to do is we're going to differentiate it. Okay, so how will I differentiate it? Let's first write it nicely. 2 into 3x plus 4 to the power half minus x. Okay, remember, and by the way, this is from May June 2021, paper 1, variant 1, paper 11 basically. May June 2021, paper 11. Okay, so make sure that you highlight or underline the word normal so that you don't forget to take the negative reciprocal of it. Okay, so let's differentiate this, see what's what. So differentiating this means dy by dx is equals to half gets multiplied by 2, which then makes it 1. Okay, or you can write it so that you don't, so that you know exactly what you've done. And then 3x plus 4 as it is, half minus 1 will be minus half, and then we have minus 1 right after. Okay, now next thing you want to do is you want to simplify before you plug in the value. Now when you have to plug in a value, don't worry too much about simplifying because ultimately you will just get one value at the end. So we now have 3x plus 4 to the power minus half. So in fact, instead of writing it as 3x plus 4 to the power minus half, I would prefer to write it as 1 upon 3x plus 4 minus 1. Okay, now remember, plugging in the x coordinate will leave us with the gradient of tangent. Okay, so if I plug in x equals to 4, so I will get the gradient, but I will get the gradient of tangent. So 1 upon 3 into 4 is 12, 12 plus 1 is 16 minus 1. So that means that the gradient of tangent is equals to 1 upon 4 minus 1, which means that the gradient of tangent is equal to what? Is equal to, wait a minute. Just let me use a calculator here. Oh. Oh yeah, made an error. Just realized that we're supposed to multiply it by 3. Okay, sorry about that. Thank you, in fact, for pointing that out. So we're going to multiply this by 3. Okay. Yeah, so dy by dx, let's do this again, is equals to 3 upon square root of 3x plus 4. Yeah, that's correct, minus 1. Okay, thank you for pointing that out, whoever did that. Now, if I plug in the value of x, so I'll just do this part directly in the calculator. So this is what we get. We get 3 upon 4. Okay, so here's what I've done. X is equals to 4. So 3 upon 4 minus 1, which means that the gradient of tangent is equals to minus 1 upon 4. Now, if the gradient of tangent is equals to minus 1 upon 4, that means that the gradient of normal would be equal to 4. Why? Because we've taken the negative reciprocal of it. Okay, so now that we have the gradient of normal, what we have to do next is that we're going to use these coordinates 4 comma 4 and form an equation. So that means y minus y1 is equals to m into x minus x1. So that means y minus 4 is equals to m, which is 4 into x minus 4. Now let's simplify this. Y minus 4 is equals to 4x minus 16, which means that y is equals to 4x minus 12. And there you go. That's it. That's the answer. Walaikum salam. Paper 12, May, June 2023. I will do that, but maybe I'll do that before, a couple of days before the exam, okay? First, I plan on doing some topical streams, and then once we're through with that, then we will do yearly past papers, okay? Anyway, so I'm not going to do part B just as yet. Let's find some more questions dealing with equation of tangent and normal. Last answer is wrong. Is it? It's y equals to 4x minus 12. Let me check. Nope, it's not. It's y is equals to 4x minus 12. There was an error initially, but I've fixed it. Okay, so this is a difficult question. Let's do this. This is from October-November 2019, paper 1, variant 1. Okay, so I want you guys to read the question, get familiar with it, and tell me, what are we going to do here? The line y equals to ax plus b is a tangent to the curve. Okay. At the point 2 comma 6, find the values of so and so. That's okay. I think we might have to use the concept of discriminant over here. Or maybe not. No, we won't have to use the concept of discriminant here. Okay, so first things first. If this line is a tangent to the curve at the point 2 comma 6, find the values of the constants a, b, and c. Okay, so first let's see what we're going to do. First of all, let's try and understand something that's very important in this question. What is that? This question here tells us that if this line is tangent, what is the gradient of this line? It's a. That means if I differentiate the equation of this curve and plug in x, then I get to, then I basically find out the gradient of this line, which is equal to a. Okay, so that means I can find out the value of a very easily. All I have to do is, like I said, just differentiate it and plug in the value of x. So let's do that. It's a 5-mark question, and I think these are 5 easy marks, considering how difficult the questions can be. So dy by dx 2 times 3 is equals to 6, so 6x square minus 10x minus 3. And because c is a constant, so what happens when you differentiate c? When you differentiate c, it just gets cancelled out. Okay, so yeah, remember that, because c is a constant, when you differentiate it, it gets cancelled out. Now we plug in x equals to 2. So if I plug in x equals to 2, so that means 6 into 2 square minus 10 into 2 minus 3. Okay, so let's see, what do we get? 6 into 4 minus 20 minus 3. So a is equals to what? A is equal to 1. So this would have given us the value of a, because it would have given us the gradient of tangent. So that means a is equals to 1. So 1 down, how many more to go? 2 more to go. Okay. Now the next thing that we need to do is we need to find out the values of b and c. Okay. So how can I find out the values of b and c? So one thing that we can do is we can find out the value of c very easily. Why? Because this y is equals to 2x cubed minus 5x square minus 3x plus c is passing through a point 2 comma 6. That means I can plug in 6. So 6 is equals to 2 into 2 cube minus 5 into 2 square minus 3 into 2 plus c. And now all I have to do is solve this for the value of c, and that's going to be the answer. So 6 is equals to 16. 5 into 4 is 20 minus 6 plus c. Let's see if I can do this mentally. 16 minus 20 is minus 4, so that's going to be minus 10 plus c. So c is equals to 16. Okay, so there you go. we now have the value of c as well. Now notice that the equation of tangent so far looks like this, considering that we have the value of a, so it's 1x plus b. Now again we have a point through which this line is passing, and that point is 2 comma 6, so that's what we're going to do. We're going to plug in 6 in place of y, and we're going to plug in 2 in place of x, and that should give us the value of b. And yeah, it does just that. B is equals to what? B is equals to 4. So B is equals to 4, A is equals to 1, and C is equals to 16. And there you go, fellas. That's the answer. Now, questions? Let's do one more question of tangent or normal before we do anything else. Okay, let's do this question. Sir, can you show this question would look on a graph as an example? What this question will look like on a graph. So we have a cubic curve, okay. Now this is just a rough representation, not exactly what it is. So we have a cubic curve, which let's say looks something like this, okay. And let's say this is the point 2 comma 6, and here is the tangent line. This is what the situation is, okay. And you have the x and y coordinates. The x coordinate is 2 and the y coordinate is 6. This is what it's going to look like, okay. Yeah, so these questions are similar to AdMaths. In fact, you will find a lot of similarity between AdMath questions and AS Math questions. Okay, this is a good question. I think we should do this. How many marks is this? It's a 6-mark question. Okay. The tangent to the curve y equals to so and so at a point A is parallel to the line y is equals to... Yeah, I think we should do this question. Okay. This is from May June 2018, paper 1, variant 3. Okay. Now, what's the keyword in this question? The keyword. Yeah, so the keyword in this is... Sir, can we DP it first? What does that mean? So this is mainly for students who have their exam in October, November. Okay. Yeah, so the keyword is parallel. What does that tell us? That tells us the gradient of tangent. Because the tangent is parallel to 2 minus 3x, and if we write this nicely, it's going to be minus 3x plus 2. That means the gradient of tangent is equal to minus 2. Why? Because of the word parallel. So that's what we're going to do. We have the equation of the curve, y is equals to x cubed minus 9x squared plus 24x minus 12. Okay. So we will differentiate this. Dy by dx is equals to 3x squared minus 18x plus 24. Okay. And then we're going to equate it to minus 2. So that means 3x squared minus 18x plus 24 is equal to what? Is equal to minus 2. All right, let me make sure that I've done everything correctly. 3x squared minus 18x plus 24 equals to minus 2. Yep, I think so far so good. No, wait, not minus 2, actually minus 3. Sorry, my bad. Minus 3, minus 3. Yeah, now it's correct. So 3x squared, let's shift everything over to the left-hand side. 3x squared minus 18x plus 27 equals to 0. Okay, I will divide this equation by 3 to make life easy. So 3 into x squared minus 6x plus 9 equals to 0. Now, if you solve this equation, x squared minus 6x plus 9 equal to 0 through middle term breaking or quadratic formula, whatever you do it, you will get one value of x and only one value of x, and that value of x is going to be equal to what? Is going to be equal to 3. Okay, you will not get two values of x. If you do get two values of x, that means you've done something wrong. Okay. All right, now. So once we have the value of x, what is it that we have to do? We have to find out the equation of the tangent at A. So notice that we have the x coordinate, we have the gradient, which is minus 3. We have the x coordinate, which is 3. Now we need to find out the y coordinate. So how will I find out the y coordinate? For the y coordinate, we're going to plug this back in. So y is equals to 3 cube minus 9 into 3 square plus 24 into 3 minus 12. Y is equals to, let's see what the value of y is. Is there any way I can? I'm afraid not. No, you can't. How did you get gradient minus 2? Actually, it was not minus 2. It was supposed to be minus 3 because the gradient we picked up from this line. The gradient of this line is minus 2. Okay. Minus 3 actually. So, and because the tangent is parallel to this line, the gradient of tangent will also be minus 3. So 3 cube minus 9 into 3 square plus 24 into 3 minus 12. Okay, so the y coordinate is 6. So that means now we have all the necessary information to find out the equation of tangent. Okay, so y minus 6 is equals to the gradient, which is minus 3 into x minus 3. Let's simplify this. Make sure we have to find out the gradient of tangent. Y is equals to minus 3x plus 9 plus 6, which means y is equals to minus 3x plus 15. And there you go, fellas. That is the answer. Now, any questions? How long will this stream continue? Probably another 15-20 minutes, not more than 2 hours. Yeah. Okay, so we're done with equation of tangent and we're done with equation of normal. Okay, so what we're going to do now is we're going to do stationary point and its nature. Okay, and we will do some questions and that should be it. Now, stationary point is basically something that is also called the turning point. Okay, why do we call it the stationary point? Because at that moment, at that instant, the curve is basically stationary. Okay, that is why we call it the stationary point. Okay, now let's let's okay, now as I said, remember stationary point is what? Is the turning point. Okay, and when we say nature, any turning point can be of two natures. Actually, there are three, but the third is not in our syllabus. But a turning point could be minimum. Okay, that is when it looks like this. Or it could be maximum. That is when it looks like this. Okay, so this is what we mean by nature of turning point. Okay, now let's, like I said, let's understand this through the help of a curve. Okay, so suppose you have a curve over here. Let's say it's a cubic curve. So a cubic curve, we know, has how many turning points? Has two turning points. Not always, okay, but normally a cubic curve has two turning points. Okay, now if I highlight the turning point, that's this one here and this one over here. Okay, now notice that the turning point is the gradient of a curve, which we find through differentiation, is basically what? Is basically the gradient of the tangent at that curve. Now, what do you think will the tangent be like if I draw the tangent at A and B. So let's say these are 2 points. One of them is A and the other is B. Okay. So let's say A has coordinates x1, y1, okay, and B has coordinates x2, y2. So what do you think the tangent will be like if I make one at A and B, considering that this is the turning point? Question for you guys. Okay, so at the turning point, the gradient of tangent is equal to 0. Why is that? Because if you make a tangent line at the turning point, the line that you will get will be a horizontal line. And we know from prior knowledge, we should know from prior knowledge that any horizontal line will have gradient 0. Okay. So any horizontal line will have gradient 0. So if you make a tangent at the turning point, the tangent is going to be horizontal, and that means dy by dx equals to 0. And that's it. That is basically how you find out the turning point of any curve. Okay, so let's do some questions to understand how this really works. So dy by dx equals to 0, and here also dy by dx equals to 0. Okay, now so let's generalize this. Let's write it down step by step how we find out the turning point or the stationary point. Okay, so how to find the turning slash stationary point. Okay, now when we say point, we mean the x and the y coordinates. Okay, or in some cases you could get multiple stationary or turning points, and you will be asked to distinguish one from the other, as in which one is maximum and which one is minimum. Okay, so step number one is that you find dy by dx. With everything, you'll notice that step 1 is always finding dy by dx. And how do we do that? By differentiating equation of the curve. Okay, then comes step 2, which is, now normally you would plug in the value of x in the equation in dy by dx to find out the gradient, but here we already know what the gradient is, because what are we finding out? We're finding out the point where the curve turns. So here, and at that point the gradient is equal to 0. So step 2 is that you equate dy by dx to 0. Okay, so equate dy by dx to 0 and solve for x coordinate of turning point. Dy by dx is going to be in terms of x. When you equate it to 0, you will get a value of x. So that would be x coordinate, or in some case coordinates of turning point, and in some cases turning points. Okay, then comes step 3, which is that you plug in the x coordinate or coordinates in some cases in equation of the curve to find y coordinates. Okay, there you go. Now, this is what you do in general. All right, just by this, I don't expect you guys to fully understand how this works. So we'll do an example. And before we do an example, let's also write down how to find out the nature. Okay, so let's do that as well. How to determine the nature. Now, if you found out the turning point and you want to distinguish which one is the maximum point and which one is the minimum point, so how do you do that? How to find the nature of turning point. Turning point or stationary point. Okay, that means how do you determine whether it's maximum or minimum? Okay, how do you determine that? So what you do is this. Step 1 is that you find dy by dx. Okay, you've already done that. Okay, you've already found dy by dx. In fact, sorry, that's not what step 1 is. Step 1 is that you differentiate dy by dx. And when you do that, you get something which is called the double derivative. Okay, what do we call it? We call it the double derivative, and this looks like this: d square y upon dx square. Okay. Now this double derivative could be either in terms of x or it could be a constant. D square y upon dx square could be in terms of x or it could be a constant. Okay. Now what do you do in both cases? When it's a constant, then it's pretty straightforward. Okay. If it is a constant, then a constant we know from prior knowledge can either be positive or negative. It's never going to be zero. If it's zero, then it's not a turning point. It's something else which is not in our syllabus, so you don't have to worry about that. So if it's a constant, there are two possibilities. Any constant can be positive or negative. So if this constant is negative, that means it's a maximum point, which means that the curve is like this. And if this constant is positive, that means it's a minimum point, which means the curve is like this. Okay. But what if it's in terms of x? That is also a possibility. If it is in terms of x, in that case, what do we do? If it's in terms of x, then you turn it into a constant. How? By simply doing this. Plug in the x coordinate or the coordinates of turning point. Now when you plug in the x coordinates of the turning point, let me write this neatly. You will have a constant again, and if you have a constant again, what does that mean? That means now all you got to do is look at the sign, whether it's positive or negative. If it's positive, it's minimum. If it's negative, it's maximum. Okay. Now I know this is all jumbled up right now, but let's do an example to see how this really works. Okay. So we'll do a past paper example straight away. Okay, let's do this question here. So this is from February, March 2019, paper 1, variant 2. It's a lengthy question, but it's pretty easy. Okay, we will find second order of derivative and plug in x. Yeah, okay, so that's exactly what we do. So it says find dy by dx and d square y upon dx square. So this question is nice in the sense that it is taking you step by step. It is first making you find out whatever is necessary to do the next step. Okay, to find out whatever the next requirement is. Okay. Now, let's see. Find dy by dx. Okay, so how will I find dy by dx? That's easy. It's written in a way that it's pretty easy for us to differentiate. So dy by dx is equal to minus 1 into 2x minus 1. We take the power, we reduce the power by 1, so that's going to be minus 2 plus 2. Okay, so that's dy by dx. If you want to write it nicely, go ahead. If you want to leave it as it is, that's perfectly all right. Okay, let me just make sure that is the correct answer. Just a minute. Yeah, okay. Now we find out the double derivative, d square y upon dx square. Okay, so how will I find out the double derivative? This is what we are going to do. Okay, wait a minute. There's something I missed again. And that is we need to multiply it by the differential of the bracket as well. So when you multiply it by the differential of the bracket, this is what we get. So dy by dx is equal to minus 2 into 2x minus 1 to the power minus 2 plus 2. Yeah, this is correct. Okay, thank you for pointing that out. Now we double differentiate it. So d square y upon dx square. So this means that this minus 2 gets multiplied by this minus 2, which makes it 4 for a minute. And then you have 2x minus 1 to the power minus 2 minus 1, which is minus 3, multiplied by the differential of the bracket, which is 2 plus 0. Okay, so the double derivative d square y upon dx square is equal to what? Is equal to 8 upon 2x minus 1, the whole thing cubed. So there you go. That is the double derivative. Okay. Now, then we have to find out the x coordinates of the stationary points, and showing all necessary working, determine the nature of the stationary point. So how do you find out the x coordinate of the stationary point? You take dy by dx, okay, and then you equate it to 0. That is how you find out the x coordinate of the turning point. So remember, I said this question is nice in the sense that it has already made you find out dy by dx. So for stationary point, what are we going to do? We're going to equate dy by dx to 0. So let's do that. Minus 2 into 2x minus 1 to the power minus 2 plus 2 equals to 0. Okay, let's see, what do we have next? So next thing that we're going to do is we're going to take minus 2 multiplied by 2x minus 1 to the power minus 2 equated to minus 2. Open a Discord server. I've thought about doing that quite a few times, but I don't know. I just don't see the benefit of it. Okay. Now, the power here is negative. We can't solve it while it's negative. So this is what we're going to do. 1 upon 2x minus 1. The whole thing square equals to 1. In fact, just swap places. So this is what you will end up with. You will end up with 2x minus 1. The whole thing square equals to plus and minus 1. Okay. In fact, not plus and minus 1. That will happen in the next step. But yeah, this is what we will have. So 2x minus 1, we'll take the square root on both sides, is equals to plus and minus 1, which means 2x minus 1 equals to 1, which means 2x equals to 2, which means x is equals to 1. Or you will have 2x minus 1, which is equal to minus 1, which means 2x is equals to 0, which means x is equals to 0. Okay. So now you have the x coordinates. Okay. But remember, that's not it. You still need to find out the nature. So in order to find out the nature, let's use the double derivative. So we have the double derivative over here. Okay. So one by one, we'll plug in the two values of x and see what we get. So let's plug in the positive value and the negative value. In fact, let's plug, they're both, well, none of them are negative. So let's plug in 1 and let's plug in 0. So if I plug in 1, let's see what we get. D square y upon dx square. We have 8 upon 2 into 1 is 2, 2 minus 1 is 1, 1 cube, which means it's greater than 0. That means this point is minimum. And then if you plug in 0, you get d square y upon dx square to be equal to 8 into minus 1 cubed, which is less than 0. That means this point is maximum. And there you go. That's it. That's your answer. Okay, now, so let's keep it till here only today. I will suggest you guys to solve the remaining questions from this worksheet, okay? And tomorrow, inshallah, we will be doing some more complex questions, okay? Some more complex concepts. In fact, we will do part 2, differentiation part 2. We will do increasing, decreasing function. We will do nature of stationary value, practical applications, and rates of change. Tomorrow, inshallah, at 6:30. So that's it. I'll stop here. If you, I hope you guys have understood all the concepts that we discussed today. If you haven't downloaded the file, I would suggest that you do that. You will find a link to it in the description. And yeah, that's that. Yeah, the updated PDF. I'll update the PDF as soon as we're done with the stream. Okay. So tomorrow we will be continuing differentiation, and then the week after we will do either M1 or S1. Okay. If I do M1, then I'll do a poll on my Instagram where I'll ask you guys what topic to stream of M1, and you guys can let me know there. Okay. So yeah.